Right now, as you are watching this, rescue teams and geologists across northern Sumatra are working through the aftermath of a magnitude 6.9 earthquake that struck one of the most tectonically complex and historically violent regions on Earth. And the specific character of this event is telling scientists something important, because it did not happen where most Sumatran earthquakes happen. At 3:22 local time on August 10th, 2026, the Indonesian Meteorology, Climatology, and Geophysical Agency, BMKG, recorded a magnitude 6.9 earthquake in northern Sumatra. With an epicenter located approximately 170 kilometers west-southwest of Medan, the country's fifth largest city and North Sumatra's provincial capital, strong shaking woke residents across the province, from Medan itself to the Coral Highlands to the outer islands off the western coast. Buildings swayed in Banda Aceh 400 kilometers to the north. The tremor was felt as far as Malaysia's Penang and the southern provinces of Thailand, but the parameter that has drawn the immediate scientific attention is the depth. This earthquake originated at 145 kilometers beneath the surface, an intermediate depth event deep inside the subducting slab of oceanic crust that dies beneath Sumatra from the Indian Ocean. That depth matters enormously. It changes how the shaking distributed at the surface. It changes the tsunami risk, which is why BMKG was able to say within 4 minutes of the earthquake that there was no tsunami threat. And it changes what this event tells us about the state of the plate boundary that produced the deadliest natural disaster of the 21st century right off this same coast less than 22 years ago. As of the time this video was produced, BMKG and Indonesia's disaster agency, BNPB, have confirmed 4 deaths, 62 injuries, and structural damage to over 340 buildings across 3 regencies of North Sumatra, primarily older masonry construction, some school buildings, and a number of Coral Highland traditional homes. Communications with several outer areas remain limited, but no mass casualty situation has emerged in the first day. Aftershocks continue and will continue for weeks. Today we break down exactly what happened at 145 kilometers depth beneath Sumatra and why deep earthquakes are geologically different from the shallow ones most people picture. The specific reason a 6.9 in Indonesia produces very different outcomes than a 6.9 in the wrong location. The shadow that the 2004 Boxing Day disaster still casts over this exact stretch of coastline, and what a modern deep event says about the shallower fault above it, and what a country that has spent 22 years building the most transformed earthquake and tsunami preparedness culture on Earth actually looks like when tested in real time. No guessing, no dramatizing, just the seismology, the history, and the real stakes for the 55 million people living along the Sumatran subduction zone. Drop a comment right now. Are you in Indonesia? In Medan? Banda Aceh? Anywhere in Sumatra, Java, or the islands? Did you feel this earthquake? And if you were in this region on December 26, 2004, tell me your city and what that morning was like. The memory of that day is written into how Indonesia now handles every event on this fault, and I want that memory in the comments for everyone else. Had you ever heard of intermediate depth earthquakes before? Today, because the physics that lets a magnitude 6.9 originate 145 kilometers underground is genuinely one of the strangest things about how our planet works. Subscribe right now if you want every major Indonesian seismic event, BMKG bulletin, and Southeast Asian geohazard development covered, as it happens, completely free. A thumbs up helps this reach the diaspora and the millions in the affected region looking for accurate information right now. Let us go for 6,000 likes now. Let us get 145 kilometers below the surface, because that is where this story begins. Sumatra sits on top of one of the great convergent plate boundaries of the planet, the Indo-Australian Plate. The oceanic crust that carries the Indian Ocean floor is diving beneath the Eurasian Plate. Along the Sunda Trench, a curving submarine trench that runs along Sumatra's entire western coast and continues past Java, the rate of convergence is roughly 5 to 6 centimeters per year, comparable to the fastest subduction rates anywhere on the. This process has built Sumatra's western mountain ranges and its arc of volcanoes, and it produces earthquakes at every depth interval you can imagine. Shallow events on the megathrust interface, where the 2 plates meet mid-crustal events on Sumatra's own strike-slip fault system running along its length, and deep events like the one that just occurred. Inside the descending slab of ocean crust that continues down into the mantle at an angle, what was that slab doing 145 kilometers underground? Something remarkable and slightly counterintuitive. Once oceanic crust subducts, it does not just glide passively downward. It cools, it heats, it dehydrates, and it experiences enormous stresses from the pull of gravity below and the resistance of the surrounding mantle. At intermediate depths, roughly 70 to 300 kilometers, a specific mechanism dominates earthquake generation there, one that has fascinated seismologists for decades. The subducting slab carries water bound inside its minerals, water that was locked up in the oceanic crust and sediments when they formed at a mid-ocean ridge, taken along for the ride as the slab dove down. As pressure and temperature increase with depth, these hydrous minerals dehydrate at specific transitions, releasing water into the surrounding rock, dramatically weakening it and allowing sudden slip-on faults that would otherwise be locked shut. By the enormous confining pressure, this is called dehydration embrittlement, and it is the leading explanation for why earthquakes even happen at depths where the pressure should, by ordinary rock mechanics to prevent any brittle failure at all. So the August 10th earthquake is very likely the product of the Indo-Australian slab, roughly 145 kilometers down beneath western Sumatra, releasing bound water at a depth where a fault segment in the slab suddenly slipped. That is different from a shallow subduction earthquake in fundamental ways, and those differences are why this event, though the same magnitude as many devastating shallow events, has produced a fraction of their damage. Depth changes everything about how surface shaking distributes. A shallow, magnitude 6.9, at 10 or 15 kilometers depth, focuses its energy into a compact area directly above the rupture, producing extreme shaking over a relatively small footprint. Catastrophic if it is beneath a city. A deep magnitude 6.9 at 145 kilometers depth spreads its energy across a much larger area with lower peak intensity anywhere. The shaking is felt farther but is less severe at any single point. This is one reason the Peru 1970 earthquake at 43 kilometers depth killed 70,000 people, while the Bolivia 1994 earthquake, one of the deepest ever recorded, at 640 kilometers, magnitude 8.2, larger than most shallow disasters, was felt across South America but killed essentially no one. Depth is the difference between concentrated devastation and distributed shaking that most structures can survive. The depth also removes the tsunami risk almost entirely. Tsunamis require vertical displacement of the seafloor, the ocean floor jumping up or down and pushing the water column above it. A deep intramasslab event, 145 kilometers underground, produces no significant seafloor deformation. BMKG's ability to state within 4 minutes that there was no tsunami threat is not a lucky call. It is direct physics applied to the recorded depth. But we have to be honest about what this earthquake does not tell us, and this is where the shadow of 2004 becomes unavoidable. On the morning of December 26, 2004, the shallow megathrust interface off the coast of northern Sumatra ruptured in one of the largest earthquakes ever recorded, magnitude 9.1 to 9.3 by later reassessments. A rupture that tore for roughly 1,300 kilometers along the plate boundary and lasted 8 to 10 minutes. The seafloor lurched upward by meters, and the ocean water above it did what ocean water does when the seafloor moves that fast. Tsunami waves reaching heights of 30 meters in some locations struck Asa at Sumatra's northern tip within 15 minutes, then swept outward across the entire Indian Ocean basin over the following hours, reaching Sri Lanka, India, Thailand, Somalia, and beyond. The final death toll across 14 countries reached approximately 227,000 people, over 165,000 of them in Aceh alone, where entire coastal cities were erased in minutes. It remains the deadliest natural disaster of the 21st century and one of the deadliest earthquakes in recorded history. That rupture happened on the shallow interface, directly above and geographically near where the August 10, 2026 deep earthquake just occurred. And the honest scientific statement is this: an intramasslab event at 145 kilometers depth tells us the slab is active and stresses continue to release in its interior. It does not directly indicate whether the shallow megathrust segments, including those that have not fully relocked and reloaded since 2004, and those adjacent segments too, the south that did not rupture in 2004 or in the subsequent 2005, magnitude 8.6 aftershock, are progressing toward their next rupture. And if so, on what timescale? The Mentawai Gap in particular, the section of the megathrust south of the 2004-2005 rupture zones off Padang and the Mentawai Islands, remains identified by seismologists as one of the world's most conspicuous unruptured seismic gaps, capable of producing another magnitude 8.59 event. Modeling by Aaron Meltzner, Kerry Siege, and collaborators on coral microatolls in the Mentawai region has documented multi-century strain accumulation across this segment consistent with a very large impending event, though the exact timing remains impossible to predict. The August 10th earthquake is not a precursor to the next great Sumatran megathrust rupture. Nothing in its character suggests that. But it is an unmissable reminder that the plate boundary, responsible for 2004, is not sleeping. It is deeply active, at multiple depths, and the great earthquake, still owed by the Mentawai Gap, is a hazard that has not been paid. Which brings us to the contrast that makes this video's message stand, because the difference between Indonesia in 2004 and Indonesia in 2026 is the largest single before and after in modern disaster preparedness anywhere in the developing world. In 2004, the Indian Ocean had no tsunami warning system, not because the technology did not exist, it did in the Pacific, but because the political and financial will to extend that coverage to the Indian Ocean had not existed. BMKG's operational earthquake monitoring at that time was thin. Public tsunami education in coastal Aceh was essentially non-existent, and the natural sign that should have prompted evacuation, or strong ground shaking itself, followed a few minutes later by the ocean unexpectedly retreating from the beach, was not recognized as a warning by most coastal residents. People who saw the ocean withdraw walked out onto the exposed seafloor to collect the stranded fish. 15 minutes later, the water came back. The transformation since is one of the great institutional stories of the 21st century. Indonesia built the INATWs, the Indonesia Tsunami Early Warning System, with dozens of seismic stations, tide gauges, and buoys, and international cooperation established the broader Indian Ocean Tsunami Warning System with 26 member states. BMKG can now issue an initial tsunami information message within 3 to 5 minutes of a significant earthquake. The coastal sirens have been installed across the most exposed communities. Vertical evacuation buildings have been constructed in Aceh, Padang, and other high-risk cities. Tsunami education is now embedded in Indonesian coastal school curricula. And the natural warning signs, strong shaking, ocean withdrawal, unusual roaring, sound, are taught explicitly. The country conducts regular drills. Every December 26th, the anniversary is marked not with silence alone, but with the practical exercises across the coastline that suffered most. The August 10th event tested that system in a small way. BMKG's information message went out within minutes. The correct call, no tsunami threat, given the depth, was made and communicated. BMPB coordinated with provincial disaster agencies. Damage was assessed, casualties were counted honestly. The response looked like a modern middle-income country handling a regional earthquake. Not like the reactive institutional shock that 2004 exposed. That transformation cost hundreds of millions of dollars in international investment and 22 years of sustained domestic institutional building. It works because it was built. It saves lives every year it exists, quietly. Without the events it prevents ever making the news. Let us be direct about the practical message. If you are in Sumatra, or anywhere along Indonesia's outer coasts, this earthquake is your reminder that the sign of a locally generated tsunami is not a text alert. It is the ground shaking hard enough that you cannot stand comfortably, or the ocean pulling back from the shore, or an unusual deep roaring sound. Any one of those three near the coast means high ground immediately. Do not wait for confirmation. Do not go to look. Do not return to your house. Coastal residents in Aceh have taught this lesson to the world at a terrible cost. Live by it. For everyone on the wider western Indonesian coast, especially those in Padang and along the West Sumatran coastline facing the Mentawai Gap, the standard preparedness applies with unusual weight, given the science. Know your evacuation route on foot, know your nearest vertical evacuation shelter, keep the go bag ready. The event that this coast has been told is coming for 2 decades is still coming. Not this week, not from an Intraslab deep earthquake, but someday. For everyone else, Understand that the November 2004 to December 2004 shift in global thinking on tsunami risk was not permanent as a memory. It fades, but it did become permanent as infrastructure. In Indonesia, at least. That infrastructure is the reason the August 10th earthquake is a story about a country that responded professionally rather than a story about mass casualties. Final thought. At 145 kilometers beneath western Sumatra, in the descending oceanic slab that has been diving into the mantle for millions of years, a fault segment released, and the slab shook itself briefly in a corner of the planet no one will ever see. The energy traveled up through the mantle, spread across a vast area of Sumatra and beyond, and arrived at the surface as a magnitude 6.9 that woke a province and killed 4 people. A serious event, and yet a tiny fraction of what the same fault system is capable of when the failure happens shallower and on the megathrust interface itself. 6,000 likes. Let us go. The Great Sumatran earthquake still owed is not this one. The event of that scale, when it comes, will look nothing like a deep quake felt across 3 countries with a modest damage report. It will look like a say looked in 2004, except that the country above it has spent 22 years building the systems that stand between the wave and the coast. Warning messages will fire in minutes, sirens will sound. Vertical evacuation buildings will fill. School children will move on the routes they have walked, in drills. Some of that will work perfectly. Some will fail under real stress in ways that cannot be foreseen. And the final measure of what preparation is worth will be counted in the survivors, not the losses. The August 10th event is a small reminder from a very large system. Take it seriously, not because this earthquake was catastrophic. It was not, but because the system that produced it has produced. The catastrophes before and the people living above it have earned, through terrible experience and painstaking rebuilding, the right to be as ready as any society on Earth for the next one. We will track the aftershock sequence, the BMKG bulletins, and every major development on the Sumatran and broader Sunda subduction system as it comes. Subscribe so you do not miss the updates, and leave that comment to your location. Your experience of this earthquake, and if you were in Aish in 2004 or anywhere the wave reached, share what your community taught the world, because that lesson is the reason today's response looked the way it did.